On the afternoon of November 4th, 2025, what began as a routine long-haul cargo mission from Louisville would evolve into one of the most tragic days in UPS Airlines history. At approximately 5:13 p.m. Eastern Time, the wide-body freighter designated as UPS Flight 2976 pushed back from its stand at Louisville's Muhammad Ali International Airport. Its destination was Honolulu's Daniel K. Inouye International Airport, a demanding trans-Pacific journey requiring a tremendous fuel load. As we begin unpacking this event, feel free to support the channel by tapping the like button, subscribing for future aviation breakdowns, and sharing your thoughts in the comments. It genuinely helps us bring more detailed investigations to you. The aircraft assigned to the flight was a McDonnell Douglas MD-11F, tail number N259UP, a trijet freighter drawing on the lineage of the DC-10 family. Although the aircraft had been a workhorse for decades, this specific airframe was 34 years old and carried a long operational history. It first served with Thai Airways after being delivered in 1991 before being converted into a freighter and acquired by UPS in 2006. 3 crew members were on board: Captain Richard Wartenberg, age 57, an Air Force veteran; First Officer Lee Trout, 45, and Relief Captain Dana Diamond, 62. As with most cargo operations, no passengers were on board. Weather conditions were calm, clear skies, light winds, and a dry runway. Nothing meteorologically hinted at trouble. But the MD-11F carried nearly 38,000 gallons of fuel, more than 220,000 pounds, to support the journey across the continent and over the Pacific. This high fuel mass demanded near-perfect aircraft performance. Any anomaly during the takeoff phase, particularly at high speed, would leave only seconds in which to respond. As the aircraft taxied toward runway 17R/35L, the crew conducted their checklists, communicating routinely and professionally. Once positioned, they advanced the throttles to take off power, and the MD-11F began its long acceleration. But only moments into the takeoff roll, something catastrophic unfolded, a failure so sudden and violent that recovery became almost impossible. Security footage and bystander recordings would soon confirm what investigators detected later in the wreckage. The aircraft's left engine, referred to as Engine Number 1, tore away from its pylon while the jet was still speeding down the runway. The separation was abrupt. As it broke from the wing, high-speed fragments likely struck surrounding structures, puncturing systems and damaging control surfaces. Flames erupted almost instantly along the left wing, and witness videos revealed bursts of fire near the tail engine as well, possibly triggered by debris entering sensitive components. Even after losing the engine, Flight 2976 continued accelerating, either because it had passed the V1 decision speed, making abort unsafe, or because the failure happened so fast the crew had no realistic opportunity to reject the takeoff. The aircraft managed to lift off the runway and reached roughly 175 feet above ground at a speed nearing 186 knots. But its condition was deteriorating by the second. The loss of thrust, the drag from structural damage, and the fire consuming the left wing created an uncontrollable left bank. Within moments, the MD-11F was descending. It clipped the roof of a UPS Supply Chain Solutions warehouse, ripping a gaping 90-meter slash through the building. The left wing then struck fuel tanks at a nearby petroleum recycling center, triggering a massive fireball. With the aircraft rolling beyond 90 degrees, it plunged into the neighboring Grade A auto parts scrapyard, still carrying its extended landing gear. The subsequent explosions, fueled both by the impact and the aircraft's immense fuel load, sent thick black smoke billowing over the city. 14 people lost their lives, the 3 crew members and 11 individuals on the ground. More than 15 others suffered injuries, and the destruction spread across half a mile of industrial property. This became the deadliest accident in UPS Airlines' existence. Emergency responders rushed to the area, confronting towering flames, collapsing structures, and hazardous materials scattered across the site. Firefighters battled multiple blazes simultaneously, while rescuers searched through the wreckage for survivors. Local authorities issued a shelter-in-place order for a 5-mile radius, instructing residents to close windows and disable ventilation systems to reduce exposure to smoke and potentially toxic fumes. The airport shut down its adjacent runway, schools canceled classes, and UPS temporarily halted operations at its massive world port hub. Within hours, the National Transportation Safety Board, NTSB, deployed a 28-member GO team, joined by Federal Aviation Administration (FAA) specialists. Their early focus centered on 3 pillars: the left engine separation, the integrity of the aircraft following recent maintenance, and the flight crew's final moments. Investigators quickly located both the cockpit voice recorder (CVR) and flight data recorder (FDR), recovering them in conditions that allowed meaningful extraction of information. One particularly chilling detail emerged from the CVR. About 37 seconds after takeoff power was applied, a repetitive warning tone filled the cockpit. That alarm persisted until the moment of impact roughly 25 seconds later. To investigators, this continuous alert indicated a severe, system-wide failure, consistent with structural separation or a major fire event. Attention soon shifted to the aircraft's maintenance history. Only 2 months earlier, N-259 had been grounded for 6 weeks due to a cracked fuel tank. During that downtime, technicians also discovered corrosion along 2 structural beams. While neither issue directly implicated the engine pylons, investigators began assessing whether these findings suggested deeper aging airframe concerns. Given the MD-11's age and history, the possibility of undetected fatigue or cumulative stress became an area of intense scrutiny. The MD-11 and its predecessor, the DC-10, share design heritage that includes pylon systems known to be vulnerable if maintenance standards lapse. The legacy of American Airlines Flight 191, another left engine separation, loomed large throughout the investigation. Although the MD-11 was heavily updated compared to the DC-10, both aircraft relied on pylon designs requiring meticulous upkeep to prevent structural cracks or fatigue. The engine pylon on Flight 2976 did not fail quietly. When it tore free, it set off a chain reaction: aerodynamic disruption, fuel line rupture, fire propagation, and potential damage to the tail-mounted No. 2 engine. With a heavy fuel load and almost no altitude, the crew faced a flight regime where recovery margins simply did not exist. As the NTSB examined the debris field, they reconstructed the aircraft's final trajectory using ADS-B data, video analysis, and wreckage patterns. The final ADS-B reading indicated that the aircraft reached just under 500 feet above sea level, barely 100 feet above the terrain, suggesting the jet never established a stable climb. The dramatic loss of lift on the left wing and the uncontrolled roll confirmed that the aircraft had entered a catastrophic aerodynamic state beyond pilot control. In the aftermath of the crash, regulatory agencies responded swiftly. The FAA issued an emergency airworthiness directive grounding all MD-11 and MD-11F aircraft pending immediate structural inspections. Boeing, which inherited the MD-11 program from McDonnell Douglas, advised operators worldwide to voluntarily suspend operations while the engine pylons underwent engineering review. UPS and FedEx, the primary U.S. operators of the model, complied, leading to major disruptions at cargo hubs across the country, including Memphis, Dallas, Fort Worth, and Ontario. These groundings rippled across global supply chains just as businesses were preparing for peak holiday shipping. Operators scrambled to reassign fleets, reroute cargo, and compensate for the loss of a significant portion of their long-range freighters. Legal consequences quickly followed. Families of victims, business owners affected by the crash, and workers from impacted industrial sites filed lawsuits against UPS, Boeing, McDonnell Douglas, and General Electric. Their allegations ranged from negligent maintenance to defective pylon design. One attorney compared the crash's force to a ground-level explosion, citing the wide radius of destruction. Many suits demanded compensation for loss of life, property damage, and environmental harm. Meanwhile, the Louisville community mourned. Vigils were held throughout the city. The Big Four bridge glowed yellow, the signature UPS color, as a gesture of solidarity. Grief counselors assisted local workers who had narrowly escaped the crash. The scene traumatized first responders, residents, and UPS employees who watched their city center transform into a disaster zone. As investigators continued analyzing wreckage, they mapped every piece across the half-mile debris field. Fire-damaged components were examined under microscopes. Specialists evaluated whether high-speed debris from the separated engine had pierced crucial systems. Engineers modeled stress loads and simulated the aerodynamic imbalance created by the sudden loss of thrust and structural support. Their work also extended to human factors analysis, evaluating the crew's final actions. The CVR will eventually reveal whether the pilots followed checklists, attempted emergency procedures, or discussed rejecting the takeoff. Because the MD-11's takeoff speeds depend heavily on weight, investigators will calculate whether V1 was passed before the engine broke free. If the failure occurred after V1, the crew legally and operationally had no choice but to continue the takeoff, despite impossible odds. The physical environment, the industrial complex bordering the runway end, also came under review. Fuel tanks, scrapyards, recycling facilities, and chemical storage sites amplified the crash's consequences. Urban planners and aviation regulators may ultimately recommend new buffer zone standards to limit hazardous operations near airport boundaries. As with all major aviation disasters, the NTSB's final report will take months, possibly years, to complete. It will determine probable cause, identify contributing factors, and issue safety recommendations likely to influence maintenance programs, aircraft aging standards, pylon design requirements, and even land use regulations near runways. For many, the story of UPS Flight 2976 is a stark reminder that cargo aviation operates with risks equal to, and sometimes greater than, passenger flight. Heavy fuel loads, aging airframes, and demanding schedules push these aircraft and crews to extreme performance margins. Takeoff, already the most vulnerable phase of flight, offers no room for major structural failures. As we await the final conclusions, airlines operating older freighters are reviewing maintenance schedules, inspecting pylon systems, and reassessing takeoff procedures under heavy loads. Regulators are preparing new directives, and communities near major airports are reevaluating the risks posed by adjacent industrial zones. For the families of the victims, the story is deeply personal. For the aviation community, it is a lesson written in tragedy. And for investigators, it is a mission to ensure that what happened to UPS Flight 2976 never happens again. If you found this deep dive valuable, consider giving the video a supportive click on the like button, subscribing for more aviation analyses, and sharing your thoughts below. Your feedback helps us continue producing detailed investigations like this one. Thank you for watching, and we'll see you in the next report.